I am coming to you today with this video, just looking at a few problems from 5.2. I did cut it down some. It was a bit, just a little bit overboard, the number of problems that were in the section, and a lot of them were just repeats. So I did try to cut it down some. I think the ones I'm working, though, are still numbered correctly because I did print my paper before I cut it down. But yeah, it'll be a lot less stress on you. Like I said, I just tried to just minimize it a little bit. So we're looking at 5.2, and I will start sharing my screen. In here. Dirty back camera board here. That's true. I can write on stuff. All right. So the first few problems, you're just finding the sum by adding the terms together. I did not find a major problem with those. Like 1 and 2, you are literally just replacing I with numbers 1 through 6 and adding them up. Similar here with number 2. And I will rewrite problems as I need to when I need more space. Same thing with number 3. So basically, the first few problems are just you working with summations. Then we get to like around number 7. Sorry, I should have written it down. Like around number 7, actually even number 7, you are still just looking at summation, and you're just giving a sum, and you're asked to write the general or the nth term of it. Okay, so we're, it looks like the bottom does not change. Notice you got n throughout here, so that stays in. But we're multiplying this term by 3 over n, so look, we wrote 3 over n out front here. And then inside of the brackets or parentheses, we've got 3 over n to the 5th power minus 3 over n, and then all the way down here to this term, we've got 3n over n to the 5th power minus 3n over n. So it appears that the top is where your I will go in, because that is where you are going to be multiplying by whatever I is for each term. Notice the first term, it looks like I was probably 1. Yeah, it says it right there. Let I be 1 for the first term. And then here we end up with n. So in your ith term for the sum, where you have n here in the parentheses, you replace those with I. But the bottom n did not change. Okay, so you're just finding the nth term. And usually that's just a little practice, and you'll have it. Just look at it carefully from this being the first term. You know, terms are separated by pluses, and then this being the last term. So 3 over n, you can write out front, or you can write at the end at the back. That doesn't matter. And then inside of the parentheses or bracket, you would have 3i over n to the 5th minus 3i over n. Okay? Number 8 is asking us to use properties of summation and the Summation Formulas theorem to evaluate the sum. So I do want to look at a few of these. Although this is the constant one, I don't see an issue with this one at all. The formulas that I'm referring to are on page, do I have this page number? Yeah, page 2 on the back there. Take a look here. You've got your summation formulas. Okay, so this is what I'm going to be looking at when it's talking about using properties of summation and summation formulas. Now this one is just a constant. So that first summation formula where you have I from 1 to n of some constant is just that constant times n. Okay, so in this case, we've got a summation of a constant, which is just like this one. So this will equal that 3, that C constant, times 6. which is 18, according to this rule. 3 times n, where n is that last number that you'll replace I with in the summation. Okay? Let's find another one that's a little bit more difficult than that one. And like I said, I did cut some of these down. Remember, I did cut some of these down. I kind of removed some problems here. So let's look at number 10. And just to make sure that my number 10 is the same as your number 10, the ID for this problem is 5.2020. Okay? So it is 5.2. And on this problem, it says use the properties of summation and the Summation Formulas theorem to evaluate the sum. Use the summation capabilities of a graph and utility to verify your results. So we've got, excuse me. Oh, I'm so sorry. I'm so sorry. So on number 10, we've got the sum from 1 to 9 of 5i minus 5. Okay. All right. So the first thing we're going to do is separate the two terms, giving them each their own summation. So summation of 5i minus summation of 5. Okay? Now, when you've got a constant times your I, that, according to one of the rules, that 5 can be pulled out front, okay? And that'll let you find the summation for I. It might be a formula that we can use for that summation of I, from I being 1 to 9. And then here, summation from 1 to 9 of just a constant, okay? So here, for I, according to one of the formulas, take a look, right here from your note, n times n plus 1 over 2 is what the sum of I is equal to. So we're able to express the summation for I as just some math computation without the summation symbol. We're actually going to just have some expression with n that we will actually be able to evaluate. Okay? So, and I still have the 5 up front. So I've got 5 times n plus 1 over 2. And then we've got minus this summation of a constant, which is just going to be that constant times that nth term, which is 9. So that's just going to be 5n. Okay? And I will replace the n with 9 in just a minute. Okay? Now, just finishing this up, we're going to replace n with 9. So 5 times 9 times 9 plus 1 over 2 minus 5 times 9. Okay. So up front still, 9 times 10 over 2, and then minus 45. So 90 divided by 2, which is what, 45? And then 5 times 45 minus 45 equals 180. Okay? Pretty straightforward, not too bad. Let's see what else we've got here. Ooh, excuse me. Ooh, let's look at number 11. I kind of like number 11. Okay. Number 11, again, I'm going to write the ID, problem ID, to ensure that your number 11 is my number 11. Should be 5.2021. And same directions, use properties of summation and the Summation Formulas theorem to evaluate the sum. So we're looking for the sum from 1 to 10 for I of I minus 1 squared. Okay? Okay? First thing I'm going to do is expand that. Since that is I minus 1 squared, let's see what happens. I'm feeling like I probably will FOIL, okay? So we've got I squared minus 1i for the inner term, minus 1i for the outer term, and then plus 1 for that last term. All right, so in the inside here, these two terms, the inner and the outer products come together to give you a minus 2i. Okay. All right, now let's separate each term and give its own summation symbol. Give each its own summation symbol. So we've got I squared minus, we'll keep the same symbols, the same signs in between the terms. Okay, so summation from 1 to 10 for I squared minus summation for 2i from 1 to 10 plus the summation for 1 from 1 to 10. All right. And then we're going to think about those summation formulas, keeping them in mind. So I squared, we do have a formula for it, okay, that allows us to simplify that without a summation symbol. Here we've got a constant times I. We're going to pull that 2 out front, and then we'll apply this formula here for the summation for I. And then lastly, we've got a constant, a summation of a constant, which would just be that constant times n, that top number n, 10. All right, so let's do it. So I'm going to pull this 2. I tell you what, we're going to understand. I'm not going to necessarily write an extra step here, but I am showing that I'm going to have this 2 multiplied by whatever I get for this I, okay? Now for I squared, I've got n times n plus 1 times 2n plus 1 over 6. Okay, that's for the first summation. Then I've got minus 2 times n plus 1 over 2. So the 2, the constant product or the constant multiple 2, and then the summation for I from the formula is n times n plus 1 over 2. And then plus the summation for a constant 1 is just 1 times n, that constant times n, all right? And we are replacing n with 10, letting n be 10, okay? So 10, the top number there, that represents n. 10 plus 1, 2 times 10 plus 1 over 6, minus 2 times 10, 10 plus 1 over 2, plus 1 times 10. Okay? Cleaning this up a bit, so we got 10, 11, 21, all over 6 here, 2, 10 times 11 all over 2, and then plus 10. So just simplifying all of that, cleaning this up nicely, 10 times 11 times 21 divided by 6. That gives me 385 right here for that. Then we've got 10 times 11 divided by 2. And then that's times 2. So that's 55 times 2. And then plus 2. So 385 minus 2 times 55. And then plus 2. 285. Okay? 285. All right, let's see. Do I have any more that I want to look at? Like I said, I tried to kind of reduce this down because it was ridiculous. Too much. 14 might be one that we should look at. It's similar to what I did from the homework. No, I'm sorry. When we were looking at notes in class, it's similar to that one. Okay. And actually, 14, because I worked one so similar to it, I'll start it off kind of, but I might go ahead and look at a different one. So let's look at 14 for just a minute to at least get it started. And this is 5.2026. Okay. So we've got the sum of j from 1 to n, and then they're going to tell us what to let n be equal to. And we got 5j plus 8 over n squared. All right. So remember, n is basically kind of like your constant. You're going to replace n with these numbers. So that n squared on the bottom, we're going to pull it out front and write it as 1 over n squared since it's on the bottom. Pulling it out front, the summation symbol. And then finding a way to express 5j plus 8 without a summation symbol. And we shouldn't have any problem doing that. Take a look here. This is a constant times j. We can pull the 5 out front. And this would just be the summation of a constant. So we'll have 1 over n squared times the summation from 1 to n for 5j plus 1 over n squared times the summation from 1 to n for 8. Okay? So that 5 is going to come out basically kind of with the n squared in a way. You could pull it over there. And so we're just trying to find a way to express the summation of j in a simplified way without the summation symbol. And here with the constant. So, and I'll go ahead and write it. Okay, so the summation for j, according to our summation formulas, it works similarly to I. Okay, summation for j, same as summation for I, n times n plus 1 over 2. So we still got 5 over n squared times n plus 1 over 2. Okay, and then here we got 1 over n squared, and this would be times 8n. Okay, and then you would just evaluate it at n equals 10, n equals 100, so on. Can you clean it up a bit? Yeah, we can keep kind of cleaning it up a tad bit. We've got 5 over n squared. On top, you got n squared plus n over 2. And then here you've got 8n over n squared. Okay? And you don't really have to do much more than this, but I mean, if you want to, you can distribute top and bottom. So this would be 5n squared plus 5n over 2n squared, and then plus 8n over n squared. Now, one thing you could do, one thing we should have done is actually reduce. Yeah, I shouldn't have distributed that because it would have been nice to just cancel it out right there, which is what I should have done. But since I've written all this, I'm going to do it here. So I'm going to pull out an n from up top here. When I pull out an n, that leaves me with 5n, and this leaves me with plus 5. And then I've got over 2n squared. And then right here, I'm going to cancel out one of those n's on top, or that n on top with one of those n's on the bottom. So that's just 8n. Right here, that n cancels with that for one of those n's. So you got 5n plus 5 over 2n, and then you got plus 8 over n. Now, if you want to get common denominators, go right ahead. You can, by all means. but you don't have to. At this point, just plug in the value of n, and when n is 10, when n is 100, 1,000, and 10,000, and just get your answer, okay? All right, let me see if there's anything else that I want to look at. Let me say something about this problem. So number 15 is asking us to use left and right endpoints and give the number of rectangles to find two approximations. Use left and right endpoints and the given number of rectangles to find two approximations of the area of the region between the graph of the function and the x-axis over the given interval. So I don't believe a graph comes with this problem, and you really kind of need one. Let's see. So I don't want to necessarily use a graph that they gave us if we, don't have it really. Well, I don't have it. So what we're trying to do is graph this particular polynomial over this interval, and then we're going to divide that interval into 4 rectangles. In all honesty, graph paper would be amazing for this problem, but we're going to make it work. We're going to definitely use the calculator to kind of get a little sketch here and some points for the graph. Although you should be okay to graph it. It shouldn't be too bad. But I'm going to put it in the calculator. So we've got 2x squared minus x minus 1. And then let's say graph. So there's the function. Yeah, it's not a terrible graph at all. Not bad at all. Let's do standard though so we can see it a little better. Even though we're focused on the graph from 3 to 5. So we'll focus on the shape or the graph, the part of the graph from 3 to 5. So I am going to sketch it though. It'll just help me if I've got the whole graph as far as by paper, having it on paper. So I'm going to go to the table so I can pull some points. Ew, those are too big. I did not expect that. I might should have reset my calculator. Yeah, let me do something. Because I did not expect that. All right, now let's put that back in. Y equals 2x squared minus x minus 1. Hit graph. All right, now let's go to the table. So I hit second graph to pull up the table. And this is more so what I wanted to see. I wanted to see some positives and negatives. And I was just going to be scrolling too long if it even got to that on the calculator. Just reset it. All right, now when we let x be 3, it looks like, let me just graph some points so I can see the graph. So I've got a point at 0, negative 1. 0, the graph is down here, negative 1. I've got a point at 1, 0. I've got a point at 2, 5. And then it just keeps on going. It gets much bigger. So I'm just going to sketch this part. Oh man, it's going to be rough. You might need to take off the problems or graph unless they give it to you. Yeah, this one. Well, it's not bad. It's just you kind of want to see the graph. That's the only thing. So, because you need those endpoints. But you can get them from the table. You can get them from the table. Okay, so the first thing we have to do is know what formula we're using per se. And we're talking about rectangles. So we're going to be using base times height. Okay, the base is the change in the x, the delta x, and that is 1/2. So how do we get that? we said delta x is equal to the endpoint b minus a over your number of, get my formula to make sure I'm telling you right, over n, yes, I'm sorry, over n, and n is just the number of rectangles, n subintervals. So n represents the number of rectangles. So it's okay, I was trying to find my formula. Oh, there it is. Okay, delta x. This is on page 6 of the notes. It came from the definition of area of a region. I was trying to find that, and I was struggling. So what we're doing is we're taking a certain region and we're dividing it into, under the curve, and we're dividing it into subintervals, okay? So the first thing you need to do is get the change in x. That's actually going to be your base, if you want to say. And then your height will represent endpoints. For the first part, it will be the left endpoint of each rectangle, where each rectangle stops at on the y-axis, or on the graph, I guess I should say. And even though you're not provided a graph, and you don't even have to sketch it. So even if your problem doesn't provide your graph, that's okay. What we're going to do is notice that you are dividing up your interval from 3 to 5 into 4 rectangles. Now, I will say that it does kind of at least help you to get the shape, kind of the image in your mind. Okay, so I had to get the width, or the change in each x, which is basically the width of each rectangle. I did have to get that. And so that's 1/2. And as you can see, this first rectangle stops, or begins at 3 and stops at 3.5, right in the middle between 3 and 4. This one starts at 3.5 and ends at 4. So they all have a base of 1/2. The delta x is the change in the x, okay? The height of the rectangle is the distance that it touches, or where it touches the graph and where it's at on the y-axis. So base times height for each rectangle. And you'll be adding those up, okay? So how can we get that without necessarily, let's say, graphing per se? You would kind of need to know that you have to partition this region. You kind of need just a little picture. You're partitioning this region into 4 from 3 to 5. So that graph is terrible. Let me flip that over. I need a little more room here. And that was at 1. Kind of hard to graph. I wish I had some graph paper. So I'm just looking at the graph of the function, and then I had a point at 0, -1. I had a point at 1, 0. I had a point at 2. What was that? 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. And then I had 3. Then I had 4, and then I had 5. Okay? So at 4, this is 2, 3, 4, 5. So remember, we're dividing the region into subintervals. I'm trying to do a sketch. Oh, where's my graph? God, this is terrible. Okay. Tricky graph. Graph paper. The graph is terrible. And we are dividing this region into 4 rectangles. Because they tell us to. Okay? The width of each rectangle is 1/2. So you will need to get where those where the height of the rectangle actually is for each of those main rectangles, main endpoints. Okay. Like I said, you really need some graph paper. It's kind of difficult to do it on there. Trying to see if I can help you. Yeah, on here they're not really wanting us to use the definition where we say area is equal to the limit. They're not really wanting us to do that here. They actually want us to approximate it using the rectangle. So I may need to take a couple more. Well, I know I took 16 off because it was requiring the picture thing with the picture, and it was just making it a little harder to graph. But here on 15, you've got endpoints, the left, which you'll be using. So that one is at 14. Yeah, 14 you're counting in twos. That one's at 20. That one's at about 27, it looks like. And that one's at 35. Now, how did I get that? All I do is I just take that number and I evaluate the function at that number. Okay? So you don't necessarily have to have a graph per se to get these endpoint values. You just need to know what delta x is, and you need to know the endpoints. Okay, and then here how they extend past it using the right endpoints. Okay, so in this case, you would just be using the value when you let the x be 3.5. Here, when you let x be 4, and when you let x be 4.5, and then you let x be 5. So, for example, let's plug in the 3 and just verify that we're going to get 14. Let's plug in 3 here. So 2 times 3 squared minus 3 minus 1. So we get 14. So it's just evaluating the function at that point. Okay? The main thing is you needed to be able to divide this space evenly, basically into 4 rectangles from 3 to 5. Okay? And then get your endpoints. So you don't have to have a picture, but you do need to kind of visually, kind of in your mind, see what you're working with. Okay? So my left endpoints, using my left endpoints, I've got an area that's slightly lower or smaller than the actual area of this region because, look, the rectangles don't actually touch all the way to the top of the line. You got some gaps here. And then you've got, using the right endpoints, the area, this one's slightly bigger. Okay, so your actual area would be somewhere in the neighborhood, somewhere between 48 and 63. That's what we're doing there, essentially. Getting a range for the area. Okay. As for this section, don't fret too much over this section. I did, like I said, cut it down. I cut it down on everything, the sub-check quiz, and I will also for the exam. Okay. So don't fret too much over that because I don't want you to be too worried or too stressed. Like that one, number 18, provided the picture, which I love that they did that. I'll put those two out. Okay. And this one says find the upper and lower sums for the region bounded. So you answer in terms of n. Okay. So your upper and lower sums, and then leave your answer in terms of n. All right, I am going to stop there with this section, and I'll be back in a little while with another video. Thank you.